When you throw a ball up in the air, roll it off a table, or play catch, the ball is experiencing projectile motion. 2D kinematics allows us to calculate elements of the ball's motion in these scenarios, such as velocity, time, and displacement. For this video, we will assume the object is in free fall, meaning that gravity is the only force on the object and there is no air resistance. Notice that when objects fall, their x velocity remains constant. However, the velocity in the y direction changes due to gravity, an acceleration of negative 9.8 meters per second squared. There are three main kinematics equations that you will use depending on the givens of the problem. We will use each in the following examples. Noah throws a chicken straight up in the air. This is a throw-up problem, so there is only velocity in the y direction. The chicken has an initial velocity of 5 meters per second. Note that at the apex, velocity is 0 meters per second. You can also see the elements of symmetry of motion. Time up equals time down, displacement up equals displacement down, and initial velocity equals negative final velocity. When Noah throws the chicken, how long does it take the chicken to return to the height he threw it from? First, list your givens. From the givens, the best equation to use is VF equals VI plus AT. Plug in your givens and solve for time. You should get 0.51 seconds. This is only the time up to the apex, so you can use symmetry of motion, which states time up equals time down to calculate the total time. Add the times together. You should get 1.02 seconds. Andrew falls asleep in physics class, causing the ball to fall off the desk. This is a cliff problem, so there's only initial velocity in the x direction. The ball leaves the desk with an initial velocity of 12 meters per second from a height of 1.5 meters. When the ball rolls off the table, what is its horizontal displacement when it hits the ground? List your givens. Remember to make displacement negative because the ball is falling down. To solve this problem, first you must calculate time. The best equation to do this with is h equals VIT plus 1/2 AT squared. Plug in your givens and remember that the initial velocity in the y direction is 0 meters per second. You should get 0.55 seconds. To find the horizontal displacement, you can use the equation dx equals vx times t. Plug in your givens and solve for dx. You should get 6.64 meters. Noah is playing football alone. Noah throws the ball with an initial velocity of 22 meters per second at an angle 35 degrees above the horizontal from a height of 2.1 meters. It is important to note that the initial velocity is at an angle, which means that in order to solve this problem, the initial velocity must be divided into its x and y components. Notice that the football moves in the shape of a parabola. This arc clearly shows the symmetry of motion that we mentioned earlier. When Noah throws the ball, what is the final velocity just before the football hits the ground? List out your givens. Next, you must divide the initial velocity into the x and y components. For the y velocity, use the formula Vy equals v sine theta. Plug in your givens, and you should get 12.62 meters per second. For the x velocity, use the formula Vx equals v cosine theta. Plug in your givens, and you should get 18.02 meters per second. Now that you have the initial velocity in each direction, you can begin to solve for the final velocity. We'll leave the x component alone for now because velocity in the x direction remains constant. Looking at our givens, the best kinematic equation to use is VFy squared equals VIY squared plus 2AH. Write out the equation, plug in your givens, and solve for VFy. You should get negative 14.16 meters per second. Now to get the final velocity, you need to combine the x and y velocities using Pythagorean's theorem. Write out the equation and plug in your givens, and you should get 22.92 meters per second. You must also calculate the angle of the final velocity using tangent. Draw a triangle of your components and use tangent theta equals opposite over adjacent to solve for theta. You should get 38.16 degrees south of east. As a recap, remember the three kinematic equations, the elements of symmetry of motion, and the three types of problems: throw-up, cliff, and cannon.